Okay, hello. It feels great to be here. Thank you, Gośka. Yesterday, we've seen a couple of great presentations and also some about Scala 3. So we have seen how Scala 3 makes the changes about the implicit things, so contextual abstractions, and we have seen how the enums changed. And today, I would like to show you opaque types. So this is something brand new. But let's begin by defining what problem we are trying to solve here. So we are trying to have the perfect model. What does it mean, perfect, for me? It means that it has to be precise in the sense that we are trying to map the reality so that our types are as close to our business domain or the things that we are modeling, so that all the intricacies and requirements and all the subtleties we can get and map in the types. We can encode it in the types. We are writing in a strongly typed language. We love when the type system helps us. So let's do that in the modeling of our domain. The second thing of our perfection is readability, so that when I'm new to the code, I look at the types and I instantly know what's happening here, what is expected of me here, and what we are going to do, what we are going to work with. And the third, and maybe most important thing, is that the perfect model prevents mistakes. So if we can make the incorrect types irrepresentable, so that then we know, then we have the confidence that if we have created something, if we are able, if the type system allowed us to create something, it means that it's probably correct. So we don't want to have some incorrect, wrong for our domain data just flying around in our system. So in Scala 2, to achieve that, we had a couple of tools. The most basic one was type aliases. So that's just a simple one-to-one mapping, but it's very basic, but it's still helpful that we're, for example, not working with integers, but we're working with ages. So that for us is a bit easier. Then we could have value classes. So that's a very popular thing. It's just a wrapper on a value, on a couple of values. And then we extend any val to prevent boxing in runtime so that it's very fast and efficient. And this is a very, very popular thing. So you probably even use it every day. And also we could have more advanced features, for example, the refined types library. So that's not a feature of the language, but it's something that you can use if you want to have your types even more clearly defined, and you can map the requirements in such a way that the type system can even prevent in compile time your errors, so it can guard your requirements. And in Scala 3, for that, we can use the new tool, which is the opaque type aliases, or opaque types. And I will show them to you right now in a live demo, where we'll see why they are called opaque, how to add API for them, and it will be both object methods and the instance methods. And the last thing that I will show will be the type bounds for opaque types. So we will be working here in this simple test case. And to make things easier, let's imagine some sample domain. Let's say that we are working in a library domain. So we are working with books. So for that, we are starting just plain old Scala 2. Let's have a case class book that we'll be working with. And the book has a title, which is a string. It has the number of pages, which is a simple integer. And the year where it was published, it will also be an integer. And this is our domain type. And for that, let's write a very simple test case. So we have an instance of a book. Let's say it's PP Longstocking, because I love this character. And it was published in 2010, and it has 350 pages. And let's write a simple assertion. We want the number of pages to equal 350. And let's run the test. It has failed. Why? Right, so this is exactly what I'm talking about. If we have simple types, then we can easily make the mistake. We are distracted, we are on stage, we are stressed. We can make the mistake, and it's very easy for that. And we want the type system to prevent that for us. So how can we fix that? Still, if we are working in Scala 2, we can have type aliases. So let's say we have a pages type, which is the same as integer, and we'll have a year type, also an integer, and maybe let's hide the test for now. And we'd like to use it here, so here's the number of pages, and here is the year. So still, here we can make the mistake, but maybe if you are working like that, we see that it's the pages type, but we can run the test, it can fail again. It's some help, but not so much. So now, where do opaque types come here? So the first thing you need to do, and actually it's the last thing you need to do, is you need to just add this opaque keyword. So now you don't have a type, you have an opaque type. And still here, nothing changes, because the compiler is still happy about that, and we can make the mistake. But let's wait, because usually when you define your types, it's not in the place when you are using there. So let's say we have some other scope, so we have object books, and let's move all our definitions there. And let's see what happens. Okay, we need to import everything from books. And then something's wrong here. So now the compiler says that it has found an integer, but it required pages. So what happens here is we are seeing a very important feature of opaque types, because what does it mean opaque? It means that something is not transparent. You cannot see through it, but it's opaque, it's hidden. And this is what opaque types are. So if you are in the scope where they are defined, then for the compiler, pages, for example, is the same as integer, it's equivalent. But when we are here out of the scope where they are defined, then the compiler only sees that it's pages. It has no idea that it's an integer inside. So how can we fix that? If you are used to value classes, then you're used to an API like that. So we have pages and year. That's what we would expect. But still, the compiler is not happy. It doesn't find such a constructor. And this is another important thing about opaque types, is that they give you no API whatsoever out of the box. So you don't have the constructor as we are used with case classes. You have nothing. So how can we work with that? We can create an object pages, which will have an apply method. So we can use that. So let's have an apply method, which will take an integer for the pages. So that's taking an integer and returning pages. And what would be the implementation of such a kind of a constructor? Is we can just pass the pages here, because we are in the scope where opaque types are defined. So for the compiler, where it expects pages, we can pass the integer. So we are using it here. And let's do the same for year. We are doing an apply method, and the year is an integer, returning year. And right now, this compiles. So probably if we run it, it will fail again. That's not a surprise. But here, it's a bit more difficult to make that mistake, because we have the named type. We actually have to provide kind of an instance of the type. So maybe if I'm not so distracted, I can spot that this is an error here. And here we're supposed to have pages. And here we're supposed to have year. But we still can make that mistake. So how do we make incorrect data irrepresentable? We can use something that you may already know, which is called the smart constructor. It's not really a feature of the language. It's just something that you can do in every language. So let's say we want to only allow the creation of an object if it's or of an instance if it's correct. So for that, let's provide another method, and let's call it a safe, as in safe construction. So also it will take the number of pages as a parameter, but it will return an option. So if what we are trying to construct is correct, then it will return a defined option. If not, it will return a none. So also we could probably use either, which would be maybe better, but option is easier for us here. So what's the implementation of such a constructor? We want to say that if we have a correct number of pages, then we actually create it. So probably if pages is greater than 0, then we are just fine. So in this case, return an instance of pages, else return a none. And we can do the same for year. So we have the save method taking the number of years, returning an option. And then what's a safe value for years? Well, I think if we are doing something like this, we'll probably save. And also, let's make sure we don't have books from the future. So less than 2024, maybe should be fine. In that case, return the year, else return a none. And how do we use such methods? Well, if we have some options, then maybe let's make a for comprehension out of that. So let's create the pages save of, do we want the safe thing or the confused thing? Let's do a correct thing for now. And then year will be year, save of 2010. And then let's return something from that comprehension. So if we have succeeded in creating pages and year, then we can have the book here. Then can we say it like this? For now, yes. So let's see if it works. So this theoretically should be a valid instance, and then valid should, or maybe valid should be defined. So what does okay, now the compiler, it has caught up and it says, no, you cannot do it like this because this is the place for pages. So it's already helpful. So let's fix it here. So we have first pages and then year. And we expect that to pass just fine. And let's see how it would look like in the case of incorrect value. So we'll just copy that and try to create an invalid instance. So for example, we can mix the order of that. So we have the year here and the pages here, because we're really distracted. And then the test case should prove to us that it should be a none. So I shouldn't be able to construct such an instance. The test passed. So it means we could have a none here, because the number of year, 350, is not okay. So this is how you add the API to your opaque types, because you don't have that out of the box. You can have simple construction. You can have such a construction method, which is kind of a static method. But what if you wanted to have instance methods on that? So for example, you would like to say book.published, and then maybe add some method like toH on this published, so on this year type. And then it should be, what, 13 probably. So what if you wanted to add such a method, if you don't really have classes here? So what you can do is you can use another Scala-free feature, which is the extension methods. So normally you use extension methods in Scala-free to add more methods to a type which is otherwise closed. And we can also use that here. So we are defining an extension on the year type. And we define this toH method. It will take the local date. So just we need to know when is now, when are we in time. And it returns an integer, because that's what we would like to have. So the body of the method is, let's take the number of years that is now and subtract the number of years from the book. And right now, the compiler should be happy about it. Let's just provide the local date of now. And it compiles. So this is the way how you would add instance methods. Maybe not just, let's run the test to see if 13 was the correct number. Yes. So this is how you add instance methods. So we have seen how to add object methods and instance methods. And that's generally it. But let me show you one more thing. Let's imagine that we also have some legacy method in our library domain. We are checking if the book should be renovated. And it takes the years as an integer, because when the method was created, we didn't know about our cool new types. And it returns a boolean of whether the year should be taken to renovation or no. So because this is a very important and complicated implementation, we don't want to just copy it to work on our types, but we would really like to use it on our types. So we would like to do something like legacy dot should be renovated, and then somehow we want to pass the published date. So it should be false. It's too new, a book. But of course, here we cannot use it because published is a year, and we don't have any method to translate it to any integer, and this should be renovated method works on integer. So what can we do? One thing we can do for sure is we can use the implicit conversion. So in Scala 2, for that, we could implement some using implicits, and in Scala 3, there's this extension, the conversion class that we can use. But that's just one way. There's also another way that you can do it with opaque types, and this is the bounds. So here where we define the year type, we can say that, in fact, this is kind of a subtype of integer. And then what happens is for the compiler, it's fine. Right now, the compiler knows that the year type is equivalent to the integer type. But it's actually much more, because what we did is we inherited the whole int API. So we can do more things with that. We can say, for example, book published plus 10 should be something, 20, what is it, 33? No, it's not, 22. Whatever, maths. But for the compiler, this is just fine, because right now we have inherited all the API of the integer in the opaque type, which means that the plus operator is also supported. So this is another thing. You don't always want to do that because it inherits the whole API, and maybe you are not happy to expose the whole API of the underlying type. But sometimes, for some of your cases, this might be what you want. So coming back to what we wanted to show you, we know what it means opaque. It's not transparent. You need to add API, and we know how to do it with object and instance methods, and we can use the bounds if that's what we want. So to sum up, the good thing about opaque types, which I love most, is that they are just simple. They are another feature of the language, but probably once you have seen it or you have used it once, you won't need to consult the documentation, and a new colleague that comes to your code will just see it, and they will already know what's defined, because it's just very clear, simple syntax. Another great thing is that they give you no overhead in runtime, so there's no boxing. Actually, the types are erased in runtime. So for our code in runtime, this would be just integers, nothing there. So good for performance. And they're opaque, which means that on your quest to the perfect model, you can hide all the implementation that you don't want to, and you can expose just the API that you want, so that the end users of your types know what's expected of them. And the things to keep in mind about opaque types is, of course, that they have no API, so no constructor, no everything. You have to write everything from scratch, unless you're happy to use bounds. But also an important thing is, for example, because they're not classes, you cannot do pattern matching on them. You cannot do the unapply method. It won't work as you would expect. And also, you cannot override toString and equals on them. So if this is something that's important in your domain, in your project, then please do keep that in mind. And if you'd like to read more, the page about opaque types in official documentation has much more to say about the bounds and why you might want to use it, and how to work with the fact that inside the defined type, the types are equal, but outside it's hidden. And if you'd like to have a look at the demo code, it's there in the GitHub repository. If you have any feedback or comments about the presentation, I'd be really grateful if you could leave it under this QR code or the link below. And if you have any questions, then I would be happy to take them now.
All right, do we have, I see a question, okay. I'm coming.
Hey, thank you for the presentation. The very first thing you said about OPAQUE type is that the compiler doesn't know the type that is hidden. And the very last thing you said, when setting up the boundary, the compiler knows the type, that it's, let's say the year was a subtype of the integer. So does it mean that the very first test you wrote works with this just passing the integer?
We can try that. So
Thanks.
our very first case was that?
Yeah,
Which
I mean,
one?
if you can construct the book just passing the integer as a year.
Oh, like that. Yeah, let's try that.
For the year.
For the year?
Yeah, because the
right.
pages
Okay,
is
for
without
pages
boundary.
we didn't provide that.
Okay.
Still no. Yeah, that's a good question. So the compiler is not so smart. You still have to have some methods to support that.
Mm-hmm. Okay, thanks.
Hi, there's a question here as well. Thank you very much for the talk. It was very good, and I think we all enjoyed it quite a bit.
Great.
I was wondering, when you said, when you use a subtyping trick to say that, I think it was page is a subtype of int, and you inherit the entire API, and if you don't want to do that, I'm not sure, because I haven't done that much Scala free, but there's also a way of exporting part of the API, right?
I'm not sure if there is.
Is there not?
I think the problem is there is not. So you either just, it is a subtype, or it has nothing to do with that.
Okay, all right. I was mistaken then. Thank you.
Thanks.
I know that there was one more question somewhere, but I don't know. Yeah, okay.
Once we added this subtyping of integer to the year, my question is, could we now get rid of this apply method, and it would work, or?
If we get rid of the apply method?
Yes, because it should know that this is the integer.
So if we construct it like that, right?
Yes. Oh, okay, it still doesn't work.
No, because
Why?
yeah, it's just this object year. It's not really a class. It's not really a constructor. This is a companion object, but it doesn't give you the magic of for example, the case class.
Okay. OPAQUE type year is something more than int, so you cannot just. Yeah, but it's here OPAQUE type year is something more than int. So if you give an int, there's not enough information. Here it is something more. It's just it has a subtype of int.
Yeah, thanks.
To be honest, I don't see too much benefit of the OPAQUE types, because you usually use it for the very simple types like year.
Right.
Okay, so when I do a year, I want to use it everywhere. And you showed that it's not possible to use it everywhere, because year is it's a property, when it's validated in context. Even this book, I can argue that when I am publisher, it's fine to have a book with a year in the future.
Right.
When I have a library, maybe it's not, because I only have a book physically that is released. So my main problem with the OPAQUE types well, in my project, they were useless.
Okay.
Because
yeah.
the validation for the very basic types like int, string, it's usually very, very contextual. And OPAQUE types don't help with that. Unless I do a book published year, book library year, PESAL year, and things like that. And then it's a lot of types for adding a boilerplate that basically no benefit from my point of view, because validation is really for the basic types a level higher on the case class or something like that. But this is just my remark.
Yeah, I can see that. So you have to see if it really helps you in your case, because as you say, this is a very simple thing for very simple types, and here we are working in the context. But maybe sometimes you find that in between. So integer is not okay for you, and the full-blown case class is also something too much for you. So maybe that would be something in between sometimes.
So for the opaque types, so if you use them like outside the same scope of the file, you have to, like the annoying thing is that you have to import both the companion object essentially,
yeah,
and the extension methods. I was wondering if you found maybe some way to make this less annoying.
I haven't tried that. I think this companion object is a bit separated from the opaque type, so I wouldn't be surprised if there wasn't a way to import it all together.
Okay, thank you.